There are two ways to do this problem, one of which is going to be to use the definition of the derivative at a point, and the other one, which you'll probably find easier simply because you've been exposed to it before, is to use L'Hopital's rule. But let's look at this in terms of the definition of the derivative at a point, because if you recognize it as such, it just deepens your understanding of what the entire body of calculus is about. So if we're going to use this approach, okay, if we're going to do it by definition of the derivative, at a point, then we need to write out and compare what the definition of the derivative at a point is. So the definition of the derivative at a point is f prime of c, in other words, the derivative of a function f of x at c, is equal to the limit as x approaches c of f of x minus f of c all over x minus c. In our case, we have the limit as x approaches 4 of e to the 3x plus 2 minus e to the 14 all over x minus 4. Well, how do you know? What's your first clue as to why this could be done by the definition of the derivative? And I would say that your first clue is that this expression here, x approaches 4, is clearly linked to this expression here, x minus 4. Because if you look back here, we have x approaches c and x minus c. Okay, so it's the same pattern. X approaches c, x minus c. X approaches 4, x minus 4. So you look for that pattern, and that is a strong indicator that this is what's going on here. Well, if that's true, if you accept that, then what you also have to accept is that this entire expression, okay, the one in green here, this expression is equal to f prime of c. Well, we would have to accept that this whole expression is f prime of c has been replaced with 4. Okay, so just by comparing the two of them, if this is equal, if the one in green is equal to f prime of c, then the one in blue is equal to f prime of 4. Now, what we'll want to do, if we want to get the derivative, is we want to know what our f of x is first. So we want to know what the basic function is first. So the f of x, let's do that in orange, highlight that in orange, f of x is this first term here. Okay, the first term on the top. So we would be saying that f of x is equal to e to the 3x plus 2. Now, this is where it's important to look at the overall meaning. We have just said that this is equal to f prime of 4. Well, if you know the shortcut, then you can go ahead and differentiate using the shortcut. You don't have to do anything else. So, let's get f prime of x. Okay, now this is in e, so when you differentiate in e, you get the same thing back again. And then you multiply by the derivative of the power. So multiply by the derivative of 3x plus 2. The derivative of 3x is 3. The derivative of 2 is 0. So it's simply 3 e to the 3x plus 2. Okay. Now, again, just a reminder, we wanted to evaluate this at f prime of 4. So when x equals 4. So just plug that in, and we get e to the power of 3 times 4 plus 2 by 3, which is going to be e to the 14 by 3, or 3e to the 14. Okay, so there's your answer. In other words, that limit that we had there originally, we didn't actually use the limit at all to find it. What we did was, instead of looking for limits, we recognized it as a derivative, we recognized what the original function f of x was, and then we just differentiated that using our shortcut rules and plugged in 4 because x is approaching 4. Okay, Excuse me. Now the other way we said you could do it is using L'Hopital's rule. So let's use L'Hopital's rule to do it as well. And remember, in an exam situation, whichever method you use is absolutely fine. So if we use L'Hopital's rule, okay. Okay, we have the limit as x approaches 4 of e to the 3x plus 2 minus e to the 14 over x minus 4. Now remember, the condition for L'Hopital's rule is that when you use substitution you get 0 over 0. So let's substitute in 4 and 4 minus 4, and if we do this on the top we get e to the 14 minus e to the 14 over 4 minus 4 is 0, so it's 0 over 0. Okay, so that means we can use L'Hopital's rule. I'll just squeeze in that there. Okay, now remember what L'Hopital's rule says. It says that the limit of the original is equal to the limit as x approaches 4, the same target for x, but you can differentiate the top and bottom separately. Now it's important that you differentiate them separately. Don't go using the quotient rule here, not for L'Hopital's rule. So differentiate e to the 3x plus 2. We've already done that. We know that it's e to the 3x plus 2 times the derivative of the power, which is 3, minus e to the 14. Well, e to the 14 is just a constant, so its derivative is 0. The derivative of x is 1. The derivative of 4 or negative 4 is 0. So you get 3, let's say it becomes the limit as x approaches 4 of 3e to the 3x plus 2 over 1, which is simply 3e to the 3 times 4 plus 2 over 1, or just as it is, which is 3e to the 14. Now whichever method you want to use is absolutely fine. You may find that you recognize it as a L'Hopital's rule question more quickly, and that's only to be expected because it's what you're familiar with previously and you're going to rely on that. I would ask though that if you're serious about developing yourself in calculus, that you think about doing it this way as well. When you go to an exam situation, fall back on the one you trust more, but certainly this is something for you to work on. The first effort where we use the definition of the derivative, that's something for you to work on and try and become more confident at. Okay, thank you.